I'm Alex Brown, and I'd like to introduce you to the Bar Grating Design Aid. This tool allows you to design the most appropriate grating size and type for structural, vehicle, or stair tread use. It takes your scenario and either selects a grating size for you or verifies if your selected size is suitable. Let's jump in. First thing I want to point out are the two tabs across the top here. Defaults to this bar grating design tab, which is just going to be general use bar grating, either for a structural or vehicular type of application. And then the second tab is stair tread design, and that's going to be literally doing a flight of stairs and designing the individual treads. So we'll walk through both, and then we'll have examples for both. Moving down a little bit, if you have a project name, job number, or your name as the engineer, all of that can be inputted here. These are optional, and really it's just so that they show up on a detailed analysis if you need to print one out. And that's going to summarize all of your inputs and outputs, just kind of give it as one handy spot, all of your information. Going into the tool itself here, the way this is set up is on the left side is all of your different inputs, and then on the right side, it's going to summarize and suggest your optimal size or do the different checks if you have a specific grating size that you're trying to look at. And then moving down the different options here, structural versus vehicular, and that's going to impact a couple of the inputs. And then if I switch to vehicular here for a second, this table pops up that just clarifies what each application means in terms of the loading assumptions per axle, the weight distribution, all of that good stuff. And that ties in right here as well. If I switch back to structural for a second, you can see the different usages here. Units, imperial versus metric, either one is supported. Span is going to be in inches, and that's going to be the span that the grating itself is trying to get across, so the spacing between supports. Configuration, standard, close mesh, ADA, heavy duty, everything is here, along with the designation that is associated with each configuration. And if you're not immediately familiar with grating sizes or the different options that are available, those are defined here as well. So just giving you a little bit of commentary on when each type of grating would be used, what type of scenario. And there's another drop down over here, bearing length requirements, and that just gives it to you in one spot, just so you know how long to make some of these panels. We do have a full piece of literature available on our steel grating product page, so extra definitions, specifications, and then right here, the steel bar grating manual will load up our full PDF. Back at the tool here, next field that we were looking at was the bar size. So pick for me, it's just going to look at whatever the loading is required for the particular usage you punched in or some of the different user overrides that are available here. It'll just suggest a size up here in the top right. So right now it's saying no good size available because we haven't had a full set of inputs yet. Alternatively, you can pick a specific size, and what that'll do is actually check for the loading, for the deflection, and give you some more detailed information on that size in this usage. Surface can be smooth or serrated. This does make a little difference because to get the serrated effect, we actually do notch out the top of the bearing bars here, so there is a slight loss of material. So that's going to play into what size is suggested, what the capacity is. If we jump over to the stair tread design tab, very similar construction to the tool here. Left side is all the inputs. So the design standard here really makes a big difference, whether it's following IBC, OSHA, or the NOM NBG 534 assumptions. And then that's going to play into kind of the geometry of the flight of stairs. So the rise or the vertical dimension, the flight, the horizontal that it's going to be spanning, and then how it divides that space into individual treads and what the minimum sizes need to be. And then similarly to the bar grating design tab, the stair tread tab here does have this user override that you can put in manual loading for it to check or deflection limits. So let's get into an example. We'll go back to the main tab here for grating. And let's say that we're looking at a structural application, maintenance catwalk. Imperial units are fine. And my supports are 5 foot on center, or 60 inches. And for the bar configuration, we'll just say standard. And I've got that 1 by 3/16 still punched in here. I'll flip that to pick for me with a smooth surface. So based on all of those inputs, it's recommending a 19W4 1 1/4 by 1/8 grating size. If I wanted to play with that a little bit, I certainly could. Put in a manual size, maybe oversize it a little bit, and it's okay for loading, okay for deflection. It's actually good up to almost 71 inches rather than the 60. So all of that looking good. Flip that back to pick for me. For my uniform load, let's say 40 PSF wasn't really the scenario I'm looking at here. I've got some really heavy loading on this catwalk, and I actually need to check it for 150 PSF. So if I punch that in and tab out, it upsized the suggestion here from 1/8 to a 3/16 thickness on my bearing bars. Let's continue kind of playing with this example here. Instead of a structural application, let's say it's a vehicle application. So that wiped out a couple of my inputs, but it kept most of them. So the usage, I need to select a new one. We'll just say a passenger vehicle. That 60-inch span is still in here from before, along with the standard configuration. So because of that, the maximum bar size isn't strong enough to support a typical passenger vehicle. If I reduce this span, maybe this is like a car wash or something, some grating that they're going to drive over, and 5-foot span really is way more than what's actually going to happen. I can drop that down to a 12-inch span now, and now I'm able to get a suggestion back, the 1 1/4 by 3/16 we were looking at before. Alternatively, if I needed that 5-foot span, standard grating just isn't going to cut it. I can kick it up to a heavy-duty grating, so a 19 HW4, and now that's given me a suggested size here. And all of this is defined here as well in this graphic, how to read that designation if you haven't seen it before. And then if we jump over to a stair example, we'll go ahead and select OSHA standard. Imperial units are fine. This will be a smooth surface as well. And for the rise, let's say this is a half flight of stairs, just 5 feet tall, 60 inches. Based on that input, that's going to set my minimum and maximum stair flight dimensions. So about 50 inches to 103 inches is the range I'm looking at for a horizontal dimension. And again, that's based on OSHA standards here. So we'll just say it's at a 45-degree angle, 60-inch rise, 60-inch run, stair width of 22 inches minimum, fine. We'll say it's 30 inches. By stair width, that's going to be, as you're going up the stairs, the left to right dimension. The step run here, 10 inches is automatically punched in. And again, that's based on stair flight, kind of managing that horizontal difference, making sure there's enough space on the tread for you to land your foot. If we play with that dimension, you can see that updated accordingly. And then based on these pretty minimal inputs here, I've got a suggested grating size, as well as a count for the number of treads that are needed, and some dimensions to fabricate it. And then that design standard, there is quite a bit of variation between the different governing bodies here. So if I flip that to like a standard IBC occupancy standard here, you can see that my 60-inch stair flight input stayed the same, but now that's way out of compliance. So I need more like a 94-inch stair flight here based on IBC versus OSHA. And that's the bar grading design aid. It's a great tool that addresses 3 scenarios where bar grading is commonly used, from structural loading for human occupancy to being driven on by vehicles or forklifts to a regular flight of stairs. And with that, happy specifying.